Next is question number 49, that is one or more option correct type. So fx is given to us dt upon ln t, and integral is from x raised to the power m up to x raised to the power n. N is greater than m is greater than 1. So we have to answer the following options. See, whenever in the integral we have function of x and here we have function of t, so we generally use Newton-Leibniz theorem. So let's use it. It says we have to find differentiation on both sides. Now on the right hand side, to find the differentiation, let's put the limit instead of t and do differentiation of the limit. Let's see how it goes. 1 upon ln of t. Instead of t we put x raised to the power n into differentiation of x raised to the power n, that is n into x raised to the power n minus 1, minus on similar pattern 1 upon ln of, instead of t, x raised to the power m into differentiation of x raised to the power m, that is m into x raised to the power m minus 1. So this is equal to x raised to the power n minus 1 minus x raised to the power m minus 1 divided by, in the denominator we have n into ln x, n is cancelled, so we are left with only ln x, right? Now for x going from 0 to 1, ln x is negative. We can see from the graph of ln x. When x is going from 0 to 1, then it is negative. So this is less than 0. Also, as n is greater than m, so when x is between 0 to 1, then x raised to the power n minus 1 is less than x raised to the power m minus 1. So both are negative. So f dash x is greater than 0. Now, also for x going from 1 to infinity, ln x is greater than 0. Also x raised to the power n minus 1 is greater than x raised to the power m minus 1. So again f dash x is greater than 0, which means that it is greater than 0 for x going from 0 to infinity. So option number A is correct, option number C is correct. Now as it is increasing function, so there is no C for which f dash c is 0. So only correct answers are A and C. Next is question number 50, which says if one root of the equation a minus b x square plus 2b plus c minus a into x minus 2 times a plus c is equal to 0 lies in 0 to 1, where a, b, c are rational numbers and a is greater than 0 is greater than b, then which of the following are correct? See, the given equation we can write it as coefficient of a is x square minus x minus 2 plus b into minus x square plus 2x plus c into x minus 2 is equal to 0. Now here we can see this can be written equal to a into x minus 2 into x plus 1 plus b into minus x can be taken common. So we have x minus 2 plus c into x minus 2 is equal to 0. So here we see that x minus 2 is a common factor. So we can write x minus 2 into ax plus a minus bx plus c is equal to 0. So x equal to 2 is one of the root and another root is x equal to a plus c divided by b minus a. As one of the root is integer and also it is given that a, b, c are rational numbers, so other root must also be a rational number. So option number A is correct, that roots of the given equation must be rational. Now as it is given that one root lies in 0 to 1, it means that a plus c divided by b minus a, it lies between 0 to 1. Also a minus b is greater than 0. So let's rewrite it as minus of a plus c divided by a minus b. Now a minus b is positive, so it can be multiplied on both sides. So we have 0 is less than minus of a plus c is less than a minus b. So further we can say a plus c is less than 0. Also we have a plus c plus a minus b is greater than 0. That is 2a plus c minus b is greater than 0. So option number C is correct and option number B is incorrect. Now option number D says that this equation has real roots. Now its discriminant is b square minus 4ac. Now see here, a is always positive but a plus c is negative, which means that c is definitely negative. So c is negative and a is positive. So this negative negative makes it positive, which means that its d is always greater than 0, which means that it always have real roots. So this is also correct. So answer is A, C and D. Next is question number 51, which says if there exist exactly 2 points on the circle with center alpha comma beta and radius 2, through which 2 perpendicular tangents can be drawn to the curve y square minus 12x minus 4y plus 16 equal to 0, then alpha comma beta may be. See, firstly, the given curve, it is y square minus 4y plus 16 equal to 12x. That is y minus 2 whole square is equal to 12x minus 12. That is equal to 12 into x minus 1. So this given curve is a parabola, and the points from which perpendicular tangents can be drawn, that is definitely directrix. Now directrix of this equation is x minus 1 equal to minus a, that is minus 3. So x equal to minus 2 is the equation of the directrix. Now it is given that there exist exactly 2 points on the circle through which 2 perpendicular tangents can be drawn. It means that this directrix is definitely cutting the circle at 2 points. Now its center is given alpha comma beta. So if we draw perpendicular from this on this line, then it is definitely less than radius, that is 2. So let's find this perpendicular distance. That is alpha plus 2 mod divided by 1. This is less than radius, that is 2. That is alpha plus 2 will go from minus to 2. That is alpha will belong from minus 4 to 0. So this is the only condition that we obtain, and there is no condition on beta. So from the given options, we can see B is possible and D is possible. So B and D is the required answer. Next is question number 52, which says integral from minus infinity to 1 of fractional part of e raised to the power x dx is equal to lambda e plus mu ln2 plus gamma, where lambda, mu, gamma are integers. So we have to answer the following options. So let's find the integral from minus infinity to 1 fractional part of e raised to the power x dx. See, let's make the graph of e raised to the power x. It is like this, where this point is 0, 1. So when x goes from minus infinity to 0, the value is less than 1. That is, it is between 0 to 1. So there we need not apply fractional part. So this is equal to minus infinity to 0 directly e raised to the power x into dx plus. Now when we talk about 0 to, when it obtains the value 2, at x equal to ln 2, the value is 2. And similarly, at x equal to ln 3, the value is ln 3, 3, but we are talking minus infinity to 1 only, which lies here. So this is from 0 to ln 2, the value will be e raised to the power x minus 1 dx, and when it goes from ln 2 to 1, then it is e raised to the power x minus 2 dx. So we just have to solve these integrals. Now integral of e raised to the power x is e raised to the power x from minus infinity to 0 plus e raised to the power x minus x from 0 to ln 2 plus e raised to the power x minus 2x from ln 2 to 1. Now it can be seen that e raised to the power x, it is going from minus infinity to 0, 0 to ln 2, then ln 2 to 1. So we can write it as directly minus infinity to 1 plus minus x from 0 to ln 2 plus minus 2x from ln 2 to 1. This is to minimize the calculation. So this is equal to e minus 0 plus minus ln 2 plus minus 2 plus 2 ln So this is equal to E minus ln 2 plus 2 ln 2, that is plus ln 2 minus 2. So comparing, we have lambda equal to 1, mu equal to 1 and gamma equal to minus 2. So lambda minus mu is 0, this is correct. Addition of all these also 0, mu is 1. So ABC is the required answer. Next is question number 53, which says consider two curves C1, that is y equal to c square minus x square, and C2, that is y equal to x square plus cx, where c is a positive constant. So we have to find the area of the region bounded by C1 and C2 for option number A. So let's firstly plot the graph of these two functions. So first one is y equal to c square minus x square. So it is a parabola like this, where this point is 0, c square, and this point is, when y is 0, it is c, 0, and this is minus c, 0. So this is curve C1. Next is C2, that is y equal to x square plus cx. So we can say y plus c square by 4 is equal to x plus c by 2 whole square. So at x equal to minus c by 2 and y equal to minus c square by 4, this is the vertex and it passes through minus c, 0. So this is the curve C2, where this point is minus c by 2, minus c square by 4. Right? So this is C2. We have to find the area of the region bounded by both of them when c is 2. So option number A. Area is equal to integral when c is 2. So this is from minus 2 to this point is c by 2, 3c square by 4. So from minus 2 to 1, the integral of c1, that is c square minus x square minus x square minus cx into dx. So this is equal to integral from minus 2 to 1, c square, that is 4 minus 2x square minus 2x into dx. So this is equal to 4x minus 2x cube by 3 minus 2x square by 2 from minus 2 to 1. Now solving this, we will get it equal to 9 square units. So option number A is correct. Now option number B. The common chord of C1 and C2 is equally inclined to the axis if C is equal to 1. Let us say this is A and this is B. So common chord is passing through A and B, that is y minus 0 is equal to 3c square by 4 divided by c by 2 plus c, that is 3c by 2 into x plus c. So the common chord is, this is cancelled. So y is equal to, in fact 2y is equal to xc plus c square. So this is the common chord. Now when c is equal to 1, then slope is not equal to plus minus 1. So this option is incorrect. Now option number C. The common chord of C1 and C2 always bisect the area of region bounded by C1 and C2. Right. So let's firstly find the total area. Total area is equal to integral from minus c to c by 2 of the one we have found in option number A, that is c square minus 2x square minus cx into dx, that is c square x minus 2x cube by 3 minus cx square by 2, and the integral is from minus c to c by 2. So solving this, we will get it equal to 9 by 8 c cube. This is the total area. Now let's find the area that is bounded by this common chord AB and the curve C1. So let us say that area is A1. So that is equal to integral from minus c to c by 2. Curve C1 is c square minus x square minus x c by 2 minus c square by 2 into dx, that is from minus c to c by 2 c square by 2 minus x square minus xc by 2 into dx. That is c square by 2x minus x cube by 3 minus x square into c by 4, and the limit is from minus c to c by 2. Now solving this, we will get it equal to 9 by 16 c cube. Now, which is half of the total area, which means that the common chord is bisecting the area of the region bounded by C1 and C2. So option number C is correct. Now option number D, the x-axis divides the area of region bounded by C1 and C2 in the ratio 23:4. Now the area we have to find is this one, that is divided by x-axis. Let us say this area is A1. So A1 will be equal to, this is the area of the parabola, so it is 2 by 3 area of this rectangle, that is c into c square by 4. So this area is equal to c cube divided by 6. Now we know the total area also, that is 9 by 8 c cube. So if we find A1 by A, so that is equal to 1 by 6 divided by 9 by 8. So this is 4 by 27. So we can see that A2 by A1 will definitely be equal to 23 by 4. So D is also correct. So ACD is the required answer. Next is question number 54, which says if two curves 2y equal to x square and y equal to fx intersect at an angle of pi by 4, then fx may be. See, let us say slope of this is dy by dx and slope of y equal to x square by 2 can be found by differentiating it on both sides, that is equal to 2x divided by 2, that is x. So we are given that mod of m1 minus m2 divided by 1 plus x into dy by dx, that is equal to tan pi by 4, that is 1. So we have dy by dx minus x mod is equal to mod 1 plus x into dy by dx, that is dy by dx minus x plus 1 plus x into dy by dx is equal to 0, or dy by dx minus x minus 1 minus x dy by dx is equal to 0, that is dy by dx is equal to x minus 1 divided by x plus 1, and from here we get dy by dx is equal to 1 plus x divided by 1 minus x. So this can be written equal to x plus 1 minus 2 divided by x plus 1, that is 1 minus 2 upon x plus 1. So we have y equal to integral of this into dx, that is x minus 2 into ln mod x plus 1 plus constant. So this is one of the curve. Now this can be written equal to minus 1 minus x, that is plus 1 minus 2 divided by 1 minus x. So dy is equal to minus 1 plus 2 divided by 1 minus x into dx. So integrating both sides, we have y equal to minus x plus 2 into integral of 1 upon 1 minus x, that is ln mod 1 minus x with minus sign, that is y equal to minus x minus 2 into ln mod 1 minus x plus constant. So from the given options, let's see, y equal to minus x minus 2 into ln 1 minus x plus constant, this is correct, or x minus 2 ln 1 plus x plus constant, this is correct. So A and D is the required answer. Next is question number 55, which says if there exists no complex number z satisfying the equation mod z square minus 2 iota z plus 2k into 1 plus iota equal to 0, then the set of real values of k may be. There is no complex number z which is satisfying this equation. So let us say z equal to x plus iota y is satisfying it. So let's put it in the given equation. Mod z will be, square root of x square plus y square. So mod z square is x square plus y square minus 2 iota into x plus iota y plus 2k plus 2k iota is equal to 0. So as this is equal to 0, so real part and imaginary part both are equal to 0, which means x square plus y square plus 2y plus 2k is equal to 0, and imaginary part, that is minus 2x plus 2k is equal to 0. So this means that x is equal to k. So putting it here, we have y square plus 2y plus 2k plus k square is equal to 0. Now, as there is no complex number which is satisfying it, so here we can say that its discriminant is less than 0. That is, there is no real value of y. So this is 4 minus 4 into 2k plus k square is less than 0. That is 1 minus 2k minus k square is less than 0. Or we can say k square plus 2k minus 1 is greater than 0. Now here its roots are k equal to minus 2 plus minus square root of plus 4 upon 2 into a. That is minus 1 plus minus square root of 2, which means k will belong from minus infinity to minus 1 minus root 2 union minus 1 plus root 2 up till infinity. So this is the range of values of k. Now the values which lie in this interval are given in B, C and D. So it is the required answer. Next is question number 56, which says consider the equation x cube minus ax square plus bx minus 1 equal to 0 has exactly two distinct real roots where a comma b belongs to R. If one root of the equation is 2 plus root 3, then possible value of a is. See, this equation has exactly two distinct real roots, which means that it have one repeated root. So there are two cases. In case 1, let's assume we have alpha, alpha, beta as the roots, where alpha is 2 plus root 3, and we have case 2 where the roots are alpha, beta, beta, where alpha is equal to 2 plus root 3, right? So here we have product of roots as 1, which means 2 plus root 3 whole square, that is 7 plus 4 root 3 multiplied by beta is equal to 1. So beta is equal to 1 upon 7 plus 4 root 3. So multiplying by 7 minus 4 root 3 in the numerator and denominator, this is equal to 7 minus 4 root 3 divided by a plus b into a minus b, that is a square, minus 16 into 3, that is 48. So this is 7 minus 4 root 3. So this is the third root in the first case. Now we need possible values of a, that is sum of roots is equal to a. So sum of roots is equal to a is equal to 2 alpha plus beta, that is 4 plus 2 root 3 plus 7 minus 4 root 3, that is 11 minus 2 root 3, that is given in option number A. So this is correct. Now in case 2, we have alpha into beta square equal to 1. So we have beta square equal to 1 divided by alpha, that is 1 upon 2 plus root 3. So multiplying by 2 minus root 3 in the numerator and denominator, so this is equal to 2 minus root 3. So from here we can see value of beta is equal to plus minus root 3 minus 1 divided by root 2. So this is the value of beta. So we need sum of roots, that is equal to a is equal to alpha plus 2 beta, that is 2 plus root 3 plus minus root 2 into root 3 minus 1, that is 2 plus root 3 plus minus root 6 minus root 2. So one of the possible values is 2 plus root 3 plus root 6 minus root 2, or 2 plus root 3 minus root 6 plus root 2. So 2 plus root 6 plus root 3 minus root 2, option number B is correct. 2 plus root 6 minus root 3, this one is incorrect. So only A and B are the correct answers.